Hello everyone, welcome to this class today about population and sampling techniques part 2. We had part 1 last week where we concentrated on what population is and what a sample is, and then we went ahead to look at the non-probability sampling techniques. Today in part 2, we are looking at the probability sampling techniques. Probability sampling techniques. The goal of probability sampling techniques is to select a reasonable number of subjects that represent the target population. Random sampling allows generalizability to a large population with a margin of error that is statistically determinable. Below, we will discuss the 5 common methods of random sampling, namely simple random, systematic random, stratified random, cluster random, and then multi-stage random sampling. Simple random sampling. This is the easiest form of probability sampling. All the researcher needs is to ensure that all the members of the population are included in the list, and then randomly selects the desired number of subjects. There are several methods to do this, but two of which are given below. One, it can just be as mechanical as picking strips of paper with the names written on it from a hat while the researcher is blindfolded. So you can put names of your respondents, names of the population in pieces of paper, fold it up, shake it, and put it in a bowl, in a basket. Then you can be able to pick them out randomly. The second way of doing simple random is to use a table of random numbers. The table of random numbers are usually included in statistics books. And alternatively, random numbers can be generated using computer programs. So in that way, when you use random numbers, you'll be able to find simple random sample. The second type of probability sampling is stratified random sampling. This is also known as proportional random sampling. Herein, the subjects are initially grouped into different classifications, such as age, socioeconomic status, or gender. Then the researcher randomly selects the final list of subjects from the different strata. It is important to note that all the strata must have no overlaps. Researchers usually use stratified random sampling if they want to study a particular subgroup within the population. It is also preferred over the simple random sampling because it warrants more precise statistical outcomes. The obvious advantage in stratified random sampling is that it ensures inclusion in the sample of the subgroup, which otherwise would be omitted entirely by other sampling methods because of their small number, because of the small number of the population. Okay, having looked at the simple random sampling and then the systematic random sampling, we now move to the third group of probability sampling called systematic random sampling. This can be likened to an arithmetic progression where the difference between any two consecutive numbers is the same. Say, for example, you're in a clinic and you have 100 patients. The first thing you do is to pick an integer that is less than the total number of the population. This will be your first subject. For example, 3. Then you select another integer, which will be the number of individuals between subject, e.g. 5. Your subjects will therefore be patient number 3, 8, 13, 18, 23, and so on systematically. Start with 3, and you add 5, get 8, add 5, get 13, add 5, get 18, add 5, get 23, add 5, get 28, and so on and so on. That is a systematic random sample. Once the population frame is randomized, the researcher then decides on the sampling interval. What we have just described as the difference of 5 is actually the sampling interval. Sampling interval is the distance between the cases that are selected for the sample. The rule of the thumb in deciding the sampling interval is to divide the total population by the sample size. If the total population is 12,000 and the sample size is 500, the sampling interval is 24, i.e. 12,000 divided by 500. And it is now, for that case, it is, when you pick, for example, a number like 4 or 3, the next will be 27, followed by 50, 52 or something like that. The interval will be 24 in this case. In systematic sampling, every case in the population frame is selected for inclusion in the sample. Every case. We had an example where every fifth person is selected. We have also got an example where every 12th person or every 24th person is selected. Those are the K cases. So a list that is arranged in alphabetical order or numerical order is not random. So don't say that I'll just list the number. Maybe I find a list of students and then you go to the registrar's office and you pick a list of students in a particular program. If they are arranged alphabetically, it's also probable that when you use that alphabetical list, the randomness may not be possible. Because there are cases, or when cases or objects are arranged in numerical order, they may follow a certain pattern. For example, size or color. Or if it is just names, there are particular tribes in Uganda where most of the names start with N and M. So you'll find the majority of the students, if they are coming from the central region, they are in the N and M group. So if you use alphabetical order and you try to go systematically, you will miss a great number of them within the N and N group. From A to from A to M, you might not find many, and after N, you might not find many. So systematic random sampling may not help if you are using alphabetical order. Therefore, picking every case subject may eliminate cases of a certain size entirely. So if, for example, the distance, this interval is 24, you will find maybe only 3 Baganda or 4 Baganda in your sample, if all majority of them are N and M. So in that way, you will not get that uniqueness that is portrayed by the Ganda. If a list of the individuals is arranged in alphabetical order, a subgroup of the population may be concentrated within one section of the alphabet. This is what I've been emphasizing. So with that, then we move to the fourth type of probability sampling called cluster random sampling. Cluster sampling is used when it is not possible to obtain a sampling frame because the population is either very large or scattered over a large geographical area, e.g. Asia. We've just talked about we have just talked about stratified random sampling, whereby you can find a list of, you can create a sampling frame, which is a list of members of a particular class. But now, when you are dealing with cluster random sampling, the population may be too big that you cannot have a frame, a sampling frame, or a sampling list. So in that case, for example, if you're going to study the whole of Asia. Asia has a very big population. I think more than half of the world lives in Asia. More than half of the world lives in Asia. So if the world has a population of coming to 8 billion, then more than 4 billion live in Asia. So that's a big population, extremely big population. So cluster sampling involves a selection of an intact group, and all the members of such a group are then included in the sample, and each member becomes a unit of observation. Example, if a doctor wants to study patients suffering from malaria in Uganda, it would be time-consuming and expensive for the doctor to try and list all the malaria patients who are hospitalized in Uganda. That's difficult. Of course, for example, you wanted to find people who are affected by malaria in Asia. That will be even a more daunting task than this one of Uganda. You cannot list all the patients who are suffering from malaria in Asia, at least in Uganda, but even then it is too big. Now, the doctor may consider it logical to confine himself to district hospitals. At least we have about 120 districts now, maybe it is more. So if you say, I take every district, one hospital, then at least you have 120 or 130. So a list of all the district hospitals would be compiled, and 1 or 2 district hospitals would be randomly selected depending on the required sample size. You can take 5 hospitals, you can take 4, depending on what you consider to be adequate. Then all malaria patients hospitalized in the selected district hospitals would then be included in the sample. If you picked Gulu Hospital, picked Kisoro Hospital, district hospital, and you pick maybe another hospital in Tororo Hospital, then you can be able to study all the patients who are hospitalized with malaria in those 3 district hospitals. At least that is manageable. You can assume that Bulu maybe has 100, Tororo maybe have 40, 50, Kisoro maybe have 30. So that is a reasonable number that you can study. So examples of, it's normally assumed that clusters are similar in characteristics. Examples of clusters are schools, towns, city estates, hospitals, large industries, government ministries, and so on. So those are clusters. Having looked at that, we can now move to the 5th, what we call multi-stage random sampling. This technique involves a combination of 2 or more sampling techniques enumerated above. In most of the complex research is done in the field or in the lab, it's not suited to use just a single type of probability sampling. Most of the researches are done in different stages, with each stage different. With each stage, a different random sampling technique being used. So multi-stage is where you have different stages of sampling. If you are studying Uganda, you have to go through stages. You have to go through stages. Like we've just talked about 130 districts in Uganda. So 130 districts, you may first of all say, I cannot study all the 130 districts. So I want to go stage by stage. Let me first sample. Let me assume I will take one district per region. And if there are 5 regions, then you know that you have 5 districts. You sample 5 districts, stage 1. Then after sampling 5 districts, then you go to the variable of interest. What are you studying? What are you studying at that variable of interest? Of course, if you are studying malaria, you can again go deep and say now, how many malaria patients are in these districts? Then you can say, can I study all the patients in the district? Probably not. Then you go again another stage and say, okay, now in a district, how many hospitals are there? Which hospitals do I select in a district? So now you keep on narrowing them. And when you get to the hospital, do I study women or men or both or what? So you keep, for example, reducing stage by stage. That is what we call multi-stage sampling, random sampling. So most of the researches are normally done in different stages, with each stage forming using a different random sampling techniques. Having looked at all the 5 random sampling techniques, we also want to look at a concept called disproportional sampling. What is this? In a probability sampling technique, we normally address the difficulty researchers encounter with stratified samples of equal sizes. Suppose, for example, a researcher desires to conduct a survey of all the students in a given university, and that university has 10,000 students. 8,000 are females and 2,000 are males. His desired sample size is 1,000. Since the 1,000 subjects needed for the survey is only 10% of the entire population, the sampling proportion is 8/10. Okay, so the proportion is 2 males for every 10 females. So this would result in a sample composed of 800 females, and only 200 males. In this case, the relatively small number of males in the sample probably would not provide adequate representation for drawing conclusions from the said survey. So what you would do, you would say, no, I have to increase the number of males to be able to fairly represent the group. Proportionality is okay because the proportion of males to females is 1:4. But if males are known to have opinions different from females, you will need to increase the number of males. The males are normally opinionated. They have opinions in everything. So if you are doing research, for example, on the political affiliation of Ugandans, and then you have political affiliation of students in Uganda, and you go to a certain university you want to study, where there are 800 females and only 200 males. If males are known to be more politically oriented, having more political opinions, then that proportion of 200 vis-a-vis 800 females will skew your results. Because the majority of the females who are in your sample, they don't have an opinion in politics. They will all say, no, I have no opinion, I have no opinion. And then the few males have opinions. Then the proportion will be skewed. So in this respect, you may have to use disproportionate sample. You increase the sample of males. If possible, you can then reduce the sample of females, because the variable you're investigating has been known to be more variable in the males than in the females. And you see, in research, we are interested in the variability. If majority of the females say, I have no opinion, 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 the results of such kind of research will not be valid in the true sense of the word, because there will be no variation. There will be no variation. And if you say you're studying 1,000 students and majority have no opinions, then that study is, you cannot now say, I am going to, the results of my study, I am going to generalize on the students of that university. It may not be generalizable because of the skewed nature of the population, and then the skewed nature of the variable being studied. So I think this brings us to the end of this subject of population and sampling. And this is a very important topic in research, because research begins and ends with methodology, and sampling is a very, very important aspect of methodology. In fact, if you do the sampling wrongly, you are likely to get wrong results. And so your results cannot be trusted, cannot be generalizable, cannot be reliable. So your sampling must be right. If you are studying phenomena where sampling is not required, that would be the best case scenario. You are studying phenomena where sampling is not required. If sampling is not required, then the variations in your sample, which is actually the same as your population, will be the same. The characteristics of your sample will be the same as the characteristics of the population. The parameters of your sample will be measuring the same parameter. The characteristics of your sample will be measuring the population parameter. But those are very rare cases that you study that your study does not require a sample. It's possible if you are studying bigger units. For example, right now there are about 40 universities in Uganda. If you want to study universities in Uganda, you can decide to study universities, but those are 40. But if you want to think that you are going to study the students in those universities, the population becomes too big. But if you want to study universities as units, if your unit of analysis are universities, most probably you will probably need secondary data to handle that kind of problem. So if you have secondary data about UCU, about KIU, about Kampala University, about Makerere, about Kyambogo, and all the other universities in Uganda, if the data is secondary data, then you can do your analysis in all the 40 universities. So you don't need to do sampling. But if you are studying students as a unit of analysis, or you're studying staff as a unit of analysis, then you are going to get into trouble. You cannot study every staff in 40 universities. You cannot study every student in 40 universities. So you'll need sampling. So the sampling techniques you use is very paramount to the results of your study. Ladies and gentlemen, we will continue with this discussion. I wish you all the best. Merry Christmas. God bless you.